That's what I'm trying to find. Okay. Okay, so I'm going to take this and I'm going to, well, the only method we can use is method 3. So we're going to apply a test source. I don't care what kind it is, so I don't put an arrow and I don't put a plus and minus, but it does have a voltage across it, the test source voltage, and it does have a current coming out of it. Test source current. Okay. I want to find everything in terms of those. Okay. So let's see, for this one, I just automatically go to node voltage. I mean, it's just easy to remember. I don't see anything in parallel that we can combine together. I don't see anything in series. So voltage division, current division. This just reeks of node voltage equation. Okay, and let's try to do this one a little more efficiently. So what should I label this node just right off the bat?
VTS.
VTS, because the test voltage, the voltage across the test source is the same as the voltage across these nodes. Okay? It's the same node. I've got the voltage VTS from here to here. Same voltage that we have from here to ground. Okay. Over here I've got another node. I'll just label that A. So far so good. Okay, so let's go over here to node A. We'll be methodical. For node A, let's see. I'm going to have this current leaving this node. Okay, so I'm going to have, let's see, what's that current going to equal?
Minus 21I delta.
Minus 21I delta. And I'm going to have the current leaving this node. What's that going to equal?
I delta.
So both those things are correct. It's equal to I delta and it's equal to VA over 700. Okay? And that's the extra piece of information that we're going to need, you know, for our controlled sources, for our dependent sources. Okay? So we have I delta, the way this is drawn, is equal to VA over 700. Okay? So we'll be able to get rid of our I deltas using that. Okay. So going this way, we'll just say, that's VA over 700. Okay. Now what do I have? Well, I need to know the current from this way. Okay. Uh-oh. That's a voltage source. I don't see any resistor in between these two essential nodes, so what am I going to do now?
Supernode.
Supernode. I love the way that sounds. Supernode. Let's see if I can figure out how to draw one. Like that. So there's a big, giant supernode. So now we have the current going here, have the current going here. Now we need to know the current going this way. What's that current going to equal? Well, it's going to equal, how can we write that? Leaving the node, VTS, with the plus to minus, it's going to be VTS minus VA. And that's going to give me the voltage here relative to this. VTS minus VA, okay, divided by 10. Okay. That's correct. Yeah. So let's just go ahead and write that. Plus VTS minus VA divided by 10. And then the last, the current going that way is going to equal
Negative ITS.
just negative ITS. I'm just going to go ahead and put the ITS over here. Okay, so we've got a node voltage equation. And we had to use a supernode, so we've just got one. And what do we have? We've got VA, we've got an I delta, Well, we can get rid of the I delta. We've got VA over 700, so let's go up here. And that's VA over 700. So now we've just got a VA, we've got a VTS, and an ITS. And so we need one more piece of information. Let's combine these just to get rid of some of this stuff. Okay, so I've got a minus 21 over 700 VA.
Negative 20.
Plus 1 over 700, so it's just going to be
Negative 20 over VA.
minus 20 over 700 times VA plus VA over 10 plus VTS over 10 equals ITS. Let's go ahead and multiply this by
70.
70. And so I can say times 70, and I can say times 70. And then I should have 70 minus 20. It's going to give me 50 over 700 times VA plus VTS over 10 equals ITS. That's a little cleaner, but I've still got VA there. And so
Is that a VA over 10 negative?
Yeah, I was just gonna say it's negative.
what did I do here?
It's ATS minus VA over 10 up on top. And then
So this is a minus.
Yeah.
Oops. Okay. So now it's minus to the 70. It's minus. Where's the 20? It's
Minus 90.
Does that look right?
Yeah. Oh, okay. Gotcha.
Okay.
Gotcha.
All right, so now we've got our VA, we've got our VTS, we've got our ITS. We've got to get rid of our VA. So what are we going to do? Any ideas? Well, we still have our relationship, okay, 300 times I delta, which is going to relate the VTS times the ITS. Usually, when we see a supernode, we have an independent source in here. In this case, it's dependent, but it's still a voltage relating these two things together. Okay? So we can use that information to find out what VA is relative to VTS. Okay? So VTS minus VA is going to equal 300 times I delta. Okay? So VTS minus VA is just going to equal 300 I delta. Okay? My I delta equals VA over 700. Okay, so let's plug in here. We've got VTS minus, now we want to get rid of the I delta, so this is going to equal, we'll say equals VA, move this VA over here, plus 300 over 700 times VA. Okay, so I just plugged in for I delta VA over 700. And now if I add these together, I'm going to have 1,000 over 700. VA is going to equal VTS. Okay. Or VTS. VA equals 700 over 1,000 VTS. So now I've got VA in terms of VTS. I can plug it back in over here. So I've got minus 90 over 700 times VA, which is going to equal 700 over 1,000, times VTS, plus 1 over 10 times VTS is going to equal ITS. Sure hope this ends up being positive. Let's see. Okay, so we can cancel out our 700s there. And we'll have minus 90 over 1,000
Minus 0.9.
plus 100 over 1,000 times VTS equals ITS. That's going to be 100 minus 90 is going to be 10. So it's going to be 10 over 1,000, 1 over 100. Okay? So this becomes 1 over 100. So I can move my 1 over 100 over to the other side, move my ITS over here, and I'll have VTS over ITS is going to equal 100. And that's equal to my RTH, which equals my RN. So we can replace all that junk with just that. And those are totally equivalent relative to these nodes. So those are equivalent. So with these, the key is you can do your node voltage, but then you typically have to use each one of these to find that extra piece of information that you're missing. And here, the relationship between these two nodes. And here, just the current, for the node voltage equation. And that I delta is related to V A. Messy. That probably took a little more than 20 minutes, so it might be a little much for an exam. So the way I'll do the exam, the way I always do them, is I will do the problems, and if I can solve it in about 7.5 or 8 minutes, I figure it's going to take you at least 20 minutes to solve it. So I try to do